Hi, here we are graphing the secant function. Okay, it's partnership with cosine, remember. So let's see. If we look at some general information about the secant function, the base secant graph is y equals secant theta, and we see that if its partner is cosine, so secant theta is 1 over cosine. So where we want to find out, well, when or where is cosine of theta equal to 0? I don't know. Check out your unit circle. You just look at it and you can find out where cosine is 0. Cosine is 0 in some different places, but naturally occurring at pi over 2 and 3 pi over 2. So, thus, at those points, secant is undefined. So the whole trick to these is not really a trick to it. I mean, all you really got to do is graph the parent function. So if it's a secant, you're going to graph cosine. If we're going to do cosecant, then you'll graph sine. So what I've done here is just essentially show you, if I just graph the y equal cosine function, starts off the max, 0, min, 0, max. Then, every time it crosses the 0 line, okay, or if I've shifted it, it would be up a little bit too, down, but in this case it hasn't. And now what happens is, when I graph it, I put in my asymptotes, because those are natural places where it's undefined, so I have to run an asymptote just at those x values. And then for the cosecant curve, all I'll do is, on those maxes, I'll just go whoop, like this. And this one would actually keep going. This one down here, whoop, right? Draw that, and then the same thing, whoop, like, just draws up like that. So the green is the actual secant curve. The blue is the cosine curve. So let's take a look and see what it looks like in real life. Okay. All right, so that's the parent. Let's look at one that's got some shifts and some crazy stuff to it here. We've got y equals 2 secant 2x plus pi plus 1. So again, amplitude 2. Period. Well, how do we find the period? We took the period over here. Period is equal to 2 pi over b. 2 pi over 2. Where do we get that 2? Right there. That's the 2. Right in front of the x. Always b. Which is pi. And then, so that's pi. So our period is pi. Phase shift. We got to figure out the phase shift. So what we do again is we set bx minus c equal to 0, right? So we set it equal to 0, not c. It looks like a c only because I put my finger on it, but it's a 0. And subtract pi, and we get pi, negative pi over here. 2x is equal to negative pi. We divide by 2, we get x equals negative pi over 2. So that is our phase shift. That also becomes our first place where we have a maximum, right? That phase shift always goes with that first max. Then we want to know, well, and then our vertical shift is up 1, and that's from this part of the function there, equation. So now, remember, we go everything by the cosine if we're doing secant. So it starts with a max, then it goes 0, then it goes min, then 0, then max. So follow everything that you would do with a cosine. I'm drawing a cosine curve. Just going to do something a little tricky at the end. Then I need to get my first max. I need to find my last max. So again, this is phase shift plus the period. We've done this a lot, so we should be familiar with this. Phase shift, so phase shift PS plus the period. That's what goes there. So that's negative pi over 2 plus pi. Common denominator, 2 over 2. So I get negative pi over 2 plus 2 pi's over 2. That leaves me with 1 pi's over 2 left. And so my max will occur at pi over 2. Now, here we go. We can fill in the rest. So it's quite easy to see that if you're negative pi over 2 and then a positive pi over 2, halfway between is 0. All right? So halfway between is 0. Halfway between negative pi over 2 and 0 is negative pi over 4. Halfway between 0 and pi over 2 is positive pi over 4. So this one has got nice, easy numbers for us, so it should be pretty good to draw. Now, I have my chart here, my graph. I'm ready to label. I've labeled my amplitude. I labeled my 0 line. It's all moved up, so I have this little black dashed line that's representing my 0. I have a max, which is an amplitude of 2 above that. So it's not actually 2. I wanted to show you that. But it's actually at 3. 2, 3. And down to 0, and then -1. So I have a max, 0, and a min line. Here's our min line. Okay, so now we're ready to draw the actual curve. So if we look at -pi/2, we are at a max. So I'll put my max dot there. At -pi/4, it comes down to a 0. Don't forget, not this 0 line, not the real 0 line, but the new one that we moved everything up for. Then we have a minimum at 0, so that's going to go right there. And then at pi/4, we've got a 0 again. So that'll go there. And then at pi/2, we have a max. So I'm first drawing my cosine curve. So my cosine curve looks like that. Pretty good for a left-handed swoop down. All right. Now, next thing I got to do is draw my asymptotes. So wherever this thing hits what I would consider a new 0, because we've shifted everything up, I am going to draw in vertical asymptotes. Vertical asymptotes right there at -pi/4 and pi/4. All right? I know the graph looks a little convoluted, but we're almost there. Now, I'm hoping you'll see this. The purple pen. Now what I got to do is I'm drawing in the cosine curve, or the secant curve. The secant curve will occur at the maximum and then again at the minimum in between the asymptotes. So this one will do something like this. All right? Goes up like that. It's kind of a bad drawing there. This one down here is going to go swoop and down. See that? Swoop down. There we go. And whoop, whoop. And then this one, and hit here, come up, go like that, and then it'll go the other side. Because this theoretically keeps moving, so I don't like to just draw half of it. I want you to see the whole thing. Anyway, so the purple really is our secant curve. If we wanted to, we can go back and get rid of the cosine curve, and what we'd have left is just the purple, which is then what you can see is the secant curve. All right? Awesome. See it? Secant? So there you go. All right. Have fun. See you soon.